Project code ITPW45. Project title: A grid interactive permanent magnet synchronous motor driven solar water pumping system. For solar water pumping system, the first is a solar panel is coupled with boost converter, and which is coupled with voltage source inverter, and this motor drive is connected to the motor, induction motor or synchronous motor. And here we using the synchronous motor because it have to tolerate the all type of load. In case the load is high means also the synchronous motor have tolerate, so the synchronous motor is used, and which is coupled with the pump. And additional in a proposed concept, the grid connector means we have to connect the grid with the voltage source converter and connected to the voltage source inverter. This setup is a bidirectional setup. This is our proposed concept. For the field oriented control technique is used to give the pulses and used to control the voltage source inverter. And existing concept, the induction motor drive is used. When induction motor used to control means it have the lot of power factor issues, and for the high power application the synchronous motor is used, and for the high torque and the high load application also synchronous motor is. So synchronous motor is best suitable for the water pumping application, and the normal sinusoidal PWM technique is used to give the pulses and control the voltage source inverter. In a proposed concept, synchronous motor is used. The main it is a torque. It is working in a high torque condition and high load, and existing mainly have the less efficiency when compared to the proposal, like the synchronous motor and the induction motor difference. And the existing concept, the only is a unidirectional because the PV is coupled with the boost converter and connected to voltage source inverter and connected to load. But it have the drawbacks of, in case the solar power is failed means we have it is very tough to compensate the load. In a proposed concept, additional grid connected is used. In case the solar panel we have get the sufficient input means the grid is activated, and using the bidirectional action of the voltage source converter and connected with the voltage source inverter, and the voltage source converter convert AC to DC, and again inverter convert DC to AC and fed to the permanent magnet synchronous motor. So additional, the bidirectional grid connector setup is used in our proposed concept. The main advantage of the proposed converter is that grid current and have the high good power factor when compared to existing. When using the induction motor, the power factor problem is there, the lagging power factor problem in existing induction motor converter. But in a proposed concept, when using the synchronous motor, the power factor is coming near to unity, and the sensorless field oriented control technique also used. By using the technique when compared to the existing PWM technique, it have good response for the varying load in a motor side or for pumping application. It's a black diagram. Solar PV is connected to boost converter and connected to voltage source inverter and motor. For backup action, grid is connected with the voltage source converter and connected with the inverter. This is the black diagram. In panel, we using the maximum power point tracking algorithm, and the duty cycle is tracked depends upon the maximum power for the particular solar radiation, and which is given to the boost converter switches. This proposed concept is used for mainly renewable energy application and energy storage application. Instead of grid, we using the battery backup also used for this system. So this concept is applied to the wide range like energy management system also, energy storage system also, and grid connected application also. This concept is used. This proposed concept is implemented using MATLAB 2015b version, and the microprocessor lab is used to in a PIC microcontroller is used for producing the pulses. For PIC microcontroller, program is fed using the microprocessor lab. Hardware minimum hardware requirement is MOSFET transformer and PIC microcontroller, 12 volt 10 watts panel, and other active and passive elements. Thank you.